Hello friends, today I am going to explain the Lewis dot structure for nitrate radical and how to write its resonating structure. So let's take the example of nitrate. So Lewis dot structure, and resonating structure for nitrate radical. Now to write the resonating structure, first we'll take the total number of electrons around the in the valence shell of each atom, right? For example, you have nitrogen in nitrate. What all atoms we have? Nitrogen. So let's count the electrons present in the valence shell of nitrogen. That is 5 plus we have 3 oxygen atom. So 3 into 6 plus 1 electron is, because of this charge, one extra electron is there. So when you count total electron, it will become 5 plus 18 plus 1, that is 24 electrons altogether you have, right? So now you need to distribute these 24 electrons in nitrate radical. Now let's see that how will you do that. So to write the Lewis dot structure, first you will take nitrogen as the central atom and write all the oxygens around it. Okay, now distribute the 24 electrons. So while distributing the electrons, right, first we'll keep the electrons 1 electrons pair in the middle of nitrogen and oxygen as a shared pair, right? So total 6 electrons we distributed, because there will be a bond between all the, how these nitrogen and oxygens are connected, right? So there must be a single bond, right? So to represent the single bond, I am keeping a pair of electron between nitrogen and oxygen each side. So total 6 electrons are distributed. After that, remaining electrons you will try to fill up or complete the octet of every oxygen atom. So let's complete the oxygen's octet, whatever electrons you have. So 6 we already distributed, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So now you distributed total 24 electrons. So by doing so, you can see that we completed the octet of oxygen. This oxygen's octet completed, this oxygen's octet completed, right? But if you see the nitrogen octet is not completed. Nitrogen is having only 6 electrons around it. Okay, so now what we need to do? So instead of arranging this way, what we can do, one of the oxygen's lone pair will remove from here and we'll keep it here. So now when I am keeping it like this, now you can see that every atom's octet is completed. Oxygens, all the 3 oxygens octet completed, as well as nitrogen's octet is also completed. Now since you have, this is nitrate, you have one extra electron which you need to show around the square bracket. Okay, so now let's write in a simplified way. I'll show you. So that's how you will write nitrogen. Now double bond means, two pairs means there will be a double bond. Okay, here you have a single bond oxygen, and this oxygen will also be connected with a single bond. Now this oxygen is having 2 pairs of electron. This is having 1, 2 and 3 pairs. This is also having 3 pairs, right? You can see that I just counted it. So this is the structure of your nitrate radical. Okay, Lewis dot structure for nitrate radical. Now let's see that how will you write its resonating structure. Now what is resonance? Basically in resonating structure, what we do, we basically delocalize the either the lone pair, or we delocalize the pi electrons without disturbing the position of the atom. So now while writing the resonating of nitrate radical, what we will do, we'll shift this pair of electron back to this oxygen, and this oxygen will keep its electron here. Okay, so when you are doing so, let's see that what will happen. So you will write the next resonating. So resonating structures, while writing the resonating structure, what you need to remember, that you need to put a double-headed arrow between the two resonating structure, right? Double-headed arrow is representing the resonating structures or the canonical forms, right? So This is the square bracket again with a negative charge, but here nitrogen. Now this double bond will change into single bond, and it will again get back its 3 lone pairs. This is as it is, we are not disturbing. And now here you will see there will be a double bond oxygen, and now this pair is shifted this side, so you will have only 2 pairs of electrons. So this is resonating structure 1, resonating structure 2. Now we can write one more resonating structure. See how I will write the next resonating structure. To write the next resonating structure, what we will do, again put a double headed arrow and write nitrogen. Now this time what will happen, this oxygen will keep its lone pair here, and these electrons will be going back to the same position. So I am basically shifting what? I am just shifting the position of pi electrons or the lone pair of electrons in different positions. So such structures which differ from each other only on the basis of the position of electrons without disturbing the position of the atom. We are not disturbing the, only the electrons are delocalized, right? So pi electrons specifically, or the lone pairs are specifically delocalized from oxygen to between nitrogen. So one by one all the 3 oxygens are sharing their pi electrons with the lone pair of electron with the nitrogen atom. That's how you will be able to write the resonating structure for nitrate. Okay, so now this will become double bond, and now this will have only 2 pair because third pair I already kept here. Okay, now this is will remain as it is, and here the double bond will now change into single bond and will have the total 3 electrons. So you can see that we can write the 3 resonating structure for nitrate. Now none of the resonating structure is the actual structure that you already know in resonance, right? So resonating structures are just a hypothetical structure. So if you write the resonance hybrid, how will you write the resonance hybrid? The actual structure of nitrogen as a resonance hybrid, we can say none of the bond is purely single nor double bond, but it will have a double bond character. All the 3 bonds will have a double bond character, and all the 3 bond lengths will be equal in your nitrate radical. Okay, so these are the resonating structure for nitrate. Hope you understood the concept. Thank you for watching this video.